In this video, we're going to look at another key property of triangles we have to investigate at this level of mathematics, and that is the altitude of a triangle. Now, in previous videos, we covered medians of triangles, so that is a line going from a vertex, so a corner, to the line opposite and cutting that line exactly in half. Altitudes of triangles have a similar-ish sort of property, but with one major difference. Now, imagine I've got this triangle here, ABC, and I draw an altitude from B to D. Now, initially this might look very, very similar to a median, but you'll notice it doesn't split it in half exactly. When it touches the opposite side, what it actually does is it touches it perpendicularly to that side, i.e. at right angles. So the altitude of a triangle from B to D is perpendicular to the side it's opposite. Doesn't cut it in half exactly, but it's always perpendicular to that side. Now, the good thing about knowing this is we can then use various other properties we've already covered with straight lines to be able to calculate the equation of the altitude of the triangle. The key property we need to make sure we remember is that the product of the two gradients of lines that are perpendicular to one another is equal to -1. So m1 times m2 equals -1. This property is going to come into play a lot when we're looking at calculating the equation of an altitude of a triangle. Now, similarly to when we did the equation of the median of a triangle, there were a few key steps that we had to do. Our first step was always to sketch it. Always draw yourself a diagram. The second thing you should then do is calculate the gradient of the side that is opposite your altitude. So calculate the gradient, we'll call it m1, of the side opposite. What this then allows me to do is use this and the property we just discussed at m1 times m2 equals -1 to then do our third step, which is calculate the gradient of the altitude. So what would be our m2 within this property right here? What we can then do is use this and the equation of the vertex from which it comes to find the equation of the altitude. It's a fairly simple set of steps, and it works every single time if we follow this same general idea. Obviously there'll be a few changes depending on the type of question, but these 4 steps will keep us in the right. So let's look at an example of this. So imagine I give you a triangle. I'm going to give you the vertices of the triangle A, B and C. I'm going to tell you that A is located at the point 3, -5. I'm going to tell you that B is located at the coordinate 4, 3. And I'm going to tell you that C is located at -7, 2. And what I want is to find the equation of the altitude from A. So that's what I want. I want the altitude from the vertex A. So the first thing you should always do is sketch it. Now, if I was to sketch this diagram here, I would end up with a triangle that looks something along these lines here. And this would be the point A, point B would be up here, and our point C would be here. Now the altitude from A goes from A directly across to the point BC. But again, key thing to mark on is because we know it's the altitude, we know it's perpendicular to those points. Let's say it cuts at the point D. Now, we have to remember our steps for calculating the equation of this line. First was to sketch it. We've got an idea of how it looks. We've got an idea what we're looking for. We have that. Second was to calculate our first gradient. So in this case, I want the gradient of the line BC. Now remember the formula for the gradient? y2 minus y1 over x2 minus x1, where the y1, y2, x1, x2 all come from the coordinates we've got here. So if you take your points and label them, so let's imagine point C is going to be x2, y2, point B is going to be the x1, y1, we end up getting 2, take away 3, divided by -7, take away 4. So 2 take away 3 gives me -1, -7 take away 4 gives me -11, so I end up with 1 over 11. So that's the first gradient I need to calculate. Second thing I now need to do is use the property m1 times m2 equals -1. I know what m1 is, that's the first gradient we've got here, m2 is what we're after. So what I know is that 1 over 11 times the gradient of my altitude m2 equals -1. So to satisfy this, I know that m2, the gradient of my altitude, is equal to negative 11. Final step we now have to do is use the vertex A to calculate our equation. So we know y minus b equals mx minus a, so in this case y take away negative 5 equals negative 11 bracket x minus the 3. Multiply this out and simplify it. Y plus 5 equals negative 11x plus 33. And again, we've got the two versions that we can write it in depending on what it's after. One form of the straight line equation, we get y equals negative 11x plus 28. The other version, we could have 11x plus y minus 28 equals 0. We could get either of those two versions would give us the equation of our straight line that we were after there. Obviously, it depends on what the question asks as to which form we would use. Finding the equation of our altitude is fairly straightforward. We just have to remember and follow these steps and use this here. This is the key property that we've covered previously that comes into play. Remembering about our perpendicular gradients and the fact that the altitude is perpendicular to the side it's opposite.